Now, when I called this a subspace, I misspoke. This is not a space. But the line is, a subspace has a little more restriction. It would have to be a line that passes through the origin. And I was a little careless when I used the term subspace. The line is a one-dimensional space. Within three-dimensional space. Okay? So, in this case, you have a single point, it's a solution, it's of dimension 0 within three-dimensional space. When you get this situation, you end up with one free variable. Your solution will have dimension 1, it'll be a line in three-dimensional space. Now we want to go on and talk a little bit about what happens if you have two rows of zeros. Okay? But before we do that, remember that if you had a row of zeros here but a non-zero number on here, that would correspond to 0 equals something besides 0, indicating you have no solution. Which would mean that two of the equations form planes that aren't parallel, and the third equation essentially coincides with one of those planes. That's not exactly true, but it's kind of an idea that's still worth thinking about. Okay, so in a minute we'll just talk about what happens if you have a matrix that reduces down to one with two rows of zeros.